Hello, everybody. Thanks for coming. It's lunchtime. Keep eating. Do not stop. Thanks for making the session. My name's Jim Carroll. I am with AWS Marketplace. I'm a category leader. I manage the network infrastructure category for Marketplace. We're going to be talking to you today about global transit networks, specifically a transit VPC, more specifically, deploying the Cisco CSR in the transit VPC topology. I'll be joined soon by Steve Savage from Infor. He's the global network architect for Infor, and he lives the day in the life of using the CSR in a transit VPC topology. So I'm going to walk through Marketplace, who we are, what we do to enable the easy deployment of a transit VPC. We'll talk a little bit more about the context of what networking in AWS is all about, what the transit VPC does to enhance networking within AWS. And then Steven's going to come on stage and give you the more real-world application of how that goes. We will not have a formal Q&A, but at the end, if you've got questions, we've got some solutions architects from Marketplace, and we've got some product management from Cisco. So we'll be in the back of the room. If anyone has some questions, just come flag us down. We'll be happy to talk to you one-on-one, but off mic. So everyone ready to go? Let's have some fun. And I was told we have a magic thingy. Oh, great. Awesome. So what is AWS Marketplace? AWS Marketplace is a digital catalog. We are a curated catalog where buyers can find and deploy software fairly quickly. We try to make it as easy as possible for you to find the products that you need to run your business. And we manage that through 35 categories, network infrastructure being one of them. But there are a bunch of other categories. We've got well over 1,200 sellers on Marketplace with over 4,000 products. And that's growing all the time. It's interesting to see that we have 160,000 active customers using software from Marketplace. And they collectively consume over 480 million hours of EC2 per month. And so what does that mean? It means it's big. It's a big service. We are one of Amazon Web Services. Marketplace writes code. We're an engineering function that just happens to have business development people. And if you were listening to Andy Jassy's keynote at all, you hear about customer obsession throughout Amazon as a company and AWS. Well, it certainly is true for Marketplace as well. We listen to our customers and we're iterating the catalog all the time to make it easier for you to find and deploy the software that you need. Some of the capabilities that we've got are just making sure that the software runs correctly. We vet all the products that are on Marketplace to make sure that it is a machine image that won't break Amazon and that you could run reliably and trust that it's going to work. For more complex topologies like the Transit VPC that leverage CloudFormation templates, we have architects in Marketplace that make sure those CloudFormation templates deploy the underlying AWS services in the order that's needed so it's easily supported not only by us, but by the sellers like Cisco. We have many options on how you can acquire the software. I'll get more into that later on. But one of the keys about Marketplace is it allows for flexibility. We hear customers all the time say that they want to see the licensing models, the way companies go about acquiring software, they're just getting tired of it. You know, the long licensing terms, the amount of shelfware that stays on a shelf, which is why it's called shelfware, right? The licenses that just wind up never getting used. If we can simplify the consumption model of software, make it easier for you to spin up the things that you need, spin them down when you're not using it, transition over to longer term subscriptions if you need to, that's what Marketplace is trying to do. And we're doing it because this is what customers are asking us to do. As I was saying, we've got multiple options for deployment. One of them is free trial. Who doesn't like free trials? But this is really critical. If you are in IT operations or if you're in IT procurement, if you've got any kind of relationship with the logos in your data center, you probably want to see those same products available for you to use on AWS Marketplace. Getting infrastructure from on-prem into AWS, we want that to happen, of course, but it will simplify your journey to the cloud if you're able to take advantage of the same scripts that you're running, the same route tables, if you've got policies and postures and profiles, personas, you want to be able to use those in Marketplace. You want to also leverage the tools that you've already invested in. If you've got familiarity with the Cisco suite in your data center, it'd be great if you could spin up a Cisco suite in Marketplace, run it in your virtual private clouds, and leverage the tools and the skill sets you've got on-prem. So that's what we're trying to do. You could check out the free trials, see if you like it. If you do, great, we hope you like it. Spin up some hourly instances and do your dev test work. When that workload's ready to go to a production environment, you could move it over to an annual license which usually gives you very significant cost savings over keeping the hourly instances up and running. If you've got a relationship with your seller and you already own licenses that give you a virtual entitlement, bring that license over. BYOL options are great. We have them all the time. In fact, the Transit VPC is a bring your own license option. There's no pay-as-you-go version of it yet, but we'll work on that. Private offers is a new capability within Marketplace that we've just recently announced. If you've got a great relationship with your seller and you want to negotiate terms and conditions and this price for this many options, this license for this kind of durability, you can negotiate straight with your seller and bring that agreed-to term to Marketplace, and we'll fulfill it for you privately, so only you see that price and only you see those terms. But it gives you a chance to negotiate with the seller, and the benefit there is the transaction stays on your consolidated AWS bill. So if you're using Service Catalog, let's say, or if you're using Cloud Center from Cisco or ServiceNow for your IT management and policy posture, you could just keep it with that, and it helps you more manage the workloads going forward. So nice options, excuse me, all great. As I said, I manage the network infrastructure category, which will be in red right there. And there is a mistake on the slide. I didn't get a chance to fix it. Brocade no longer exists. They just were recently purchased by Broadcom, so that logo needs to come down. But roughly there, you can see Cisco's on top. They're great for us. You're going to see a lot of other logos that you recognize, hopefully. If you're managing a data center, you're moving workloads over to AWS, you want to see the look and the feel stay consistent with what you've got on-prem. So you're going to see a lot of logos that work. I'd like to also point out, though, that even though we're focusing on the Cisco Cloud Services Router today, there are other sellers that have topologies for the Transit VPC. We're not going to talk about them today, but many of them are in the expo. So I encourage you to swing by and talk to Riverbed. Their Steel Connect product is great. Also, we've got Barracuda, Palo Alto, Fortinet, and Sophos. They each have options for Transit VPC. There's a company that's not up here called Aviatrix. They've got a booth here. Juniper is emerging with one, but we're not going to cover those guys. But if you see a logo up there, you want to have a conversation with someone, swing by their booth at the expo, maybe with a glass of wine in hand, and have a good conversation. Deploying Marketplace software is, like I said, we're trying to make it as simple as possible. Most software is single-click deployment. We encourage all software to be single-click deployment. And why is this important? It is meant to simplify your ability to deploy the software, but you'll also know that Marketplace has vetted that AMI, that Amazon Machine Image, to work. Even if you could buy the software yourself and spin up an EC2 instance and slap on an operating system, and you could build your own virtual appliance if you would like, or you could trust that we've built it already on behalf of you. Single-click deployment allows you to take advantage of that. What's new with Marketplace is the ability to take the software that you subscribe to and insert it into Service Catalog. We won't get very much into Service Catalog right now. There are a lot of sessions on Service Catalog. But Service Catalog is a way for you to manage the catalog of software that you've subscribed to from Marketplace or built on your own and put in there, so you can come up with postures and profiles and personas within Service Catalog and make sure maybe your test dev are able to only get these instances of software, and maybe your production can get only those instances of software. You can define that in Service Catalog. Marketplace software is now compatible to be plugged in with Service Catalog, helping to simplify things. Right there you see a screenshot of Marketplace, how products get listed. You're looking for Cisco, which is awesome. If you want to know a little bit more about the Transit VPC, you type in Cisco Transit, there you go. There's the option right there for a bring your own license instance of the Transit VPC topology. When you click next, it brings you to the detail page so you can see more about what's going on. You hit, excuse me, you hit continue, you log into your AWS credentials, bam, you're there, you're ready to go. This will deploy a CloudFormation template with multiple versions of lots of other things that Steve will get into. I won't, but that's it. It's as simple as that. And what is a Transit VPC? Before we get into that, let's back up a little bit and talk a little bit about networking in AWS, period. Hopefully most of you guys already know this. The one we're going to focus on is the Virtual Private Cloud, a VPC, which is an abstraction. It's a logical instance of Amazon's networks that you manage. You could bring your own IP addresses. You could manage private subnets, public subnets. You could do NAT gateways. You could do all sorts of great things. And we'll get more into that later on. It's nice to show it in the context of the other things that we've got. Direct Connect, which is a high-speed interconnect between an AWS VPC in your colo or an AWS VPC in your on-prem data center, 1 gig, 10 gig connections that you could manage. Elastic Load Balancer, if you've been following the trajectory of Elastic Load Balancer, that's really a suite of load balancers that do anything in layer 4 through 7 networking services. And Route 53, which is our domain name service. We won't cover those much. It's mostly going to be on the VPC, which, as I said, allows you to really just create your own virtual private cloud, an abstraction of our network that you control and you manage. It leverages underlying AWS resources quite heavily. It's built to be scalable, elastic, deployable where you need it to be, and it has a variety of connectivity options that allow you to do great things from VPC to VPC connectivity, VPC to on-prem connectivity. You could do, like I said, public addresses. You could do private subnets that you could NAT gateway if you need to. And it's ideal, obviously, for websites and things like that, but it's spectacular also for multi-tier, multi-level applications. You can have a VPC for your web presence. You can have a VPC for your application. You can have a VPC for your database. You can connect them together, and everything's fine. As companies are migrating over to AWS, though, maybe some of those applications or maybe that database is architected in a way where it's just not an elegant move. You want to keep it on-prem. No worries. The VPC can connect to your on-prem stuff, and you'll be able to manage a multi-tier application that way pretty elegantly. And the Transit VPC certainly helps out in that, so be mindful of that when we start talking about it more. A Transit VPC is a network hub that you create where you route traffic through it. That's pretty much it. Without a Transit VPC, you need to peer VPCs together. And as you get into the dozens or hundreds of VPCs, VPC peering can get a little squirrely. You're managing a lot of connections, and it just sometimes becomes inelegant. A Transit VPC reduces the number of connections and allows you to create spokes into the Transit VPC hub. And the Transit VPC hub then does your routing. You can do a lot of other things. You could connect it to a shared services VPC for intrusion detection or firewall capability, but it's a way of more elegantly managing the traffic. You could still use peering along with the Transit VPC, and we encourage you to do that because you don't want necessarily all of your traffic going through the VPC, the Transit VPC. You get network contention, you'll get bottlenecks. To leverage it with peering allows you to keep the network clean and reduce the hops. Well, there won't be many hops, but the network contention, so latency will not be an issue. So that's the best practice right there. The Transit VPC, it's completely virtual. You don't have to go to your colo and spin up some hardware. It's completely virtual. It's a couple of CSRs in the availability zones that you manage from there. It leverages underlying AWS networks. And as I said, you can also peer it to shared services. You don't want to run too many shared services, if any, in your Transit VPC. You just want that VPC to be running those CSRs and working as a Transit VPC. If you need additional networking services, spin those up in a shared services VPC and you work it from there. That's fine. But it's completely virtual. It's dynamite. It solves a lot of problems, and it reduces the complexity, which is really the nice part about it. As I was saying, this is a more graphical representation of what a VPC, Transit VPC looks like. You can see in the middle, there you go, a representation of a couple of Cisco CSRs in availability zones to make sure that it's a robust network. You could connect them to as many other VPCs as you require, easily connected to your corporate data center or even some other cloudy thing if you choose to do that too. It's a nice, elegant way of getting it done. And the benefits to it for using the Cisco CSR is Cisco's world-class routing with built-in security features with the Cloud Services Router. If you're a Cisco shop, you got some ASRs running in a branch, an ASR running in the data center and some ISRs running in the branch, you already know the operating system. The CSR is built on the same OS. It uses the same tools, same routing tables, same everything. So you can elegantly spin up the CSR in a Transit VPC topology, and you're ready to go. If you're a Cisco shop, it's dynamite for that. It also is a robust security feature in its own thing, but really it's the cost efficiencies of leveraging the tool set you've got, the skill set. You know, you're smart on that stuff already. Go ahead and use it. We highly encourage you to, even if you're not using the Cisco version of the Transit VPC, deploy it off of Marketplace, even if it's a BYOL instance, you already paid for the license. The instances deployed off of Marketplace, again, I cannot stress this enough. They've been vetted by us. We've worked by that vendor. We know those virtual appliances will work. You could build it yourself if you'd like, but we highly encourage you to do it off of Marketplace just as a best practice. And that's about it for me. Right about now, we're going to have Steve come up and talk a bit more about a day in the life using the Cloud Services Router in a Transit VPC topology. Steve's with Infor. He'll tell you a little bit more about the company, and we're going to go from there.
Thank you. Thanks, Mike. So hey, everyone. My name is Steve Savage. I'm Global Network Architect with Infor. And I want to talk to you today about our Transit VPC use case. So let me just flick forward here. The Infor is an enterprise software provider, and we design software solutions per industry. And to really illustrate our use case of the Transit VPC, it pays to go back a little bit, maybe about 2.5 years ago, to where we first started out in AWS. So this slide here is probably something most people are relatively familiar with. It's, this is a data center extension and how we ultimately began our journey in AWS. So I work in the Business Innovation Group, which covers internal IT. And as I said, about 2.5 years ago, we built our first data center extension. So this solution homed a lot of IT services. So we have stuff like domain controllers, some IT workloads, and we started to migrate some internal applications as well. This is all internal, nothing public at this point, really. Small minor public presence, but mainly it was an internally routed environment. And what is kind of relevant about this particular slide is the WAN connectivity element. So if you look out to the left there, you'll see the CSRs that Jim was mentioning. So the reason we leverage CSRs, because you've got a lot of options here. I mean, you could use Direct Connect or IPsec or a myriad of different connectivity options to connect to your WAN infrastructure from AWS. So we chose the CSR 1000V because, as Jim was mentioning, we are a big Cisco shop. We've got a lot of ISRs, and our workforce is very dispersed. We're a global organization. Our folks are all over the world, and we don't have centralized product teams. Like, so we don't have a certain product with people all in one office and another product with people all in another office. They're very spread out. And we've got a lot of home users, work users, and branch offices worldwide. So for us, we were able to use the CSR 1000V because it's essentially a virtualized form factor of the ASR. And because of that, we can leverage all the same technologies, the same feature sets that we have on-premise. So we use DMVPN for our WAN connectivity. And that allows us to have single spoke connectivity between all branch offices. So in essence, this environment looks just like another Infor office for us. All of the facilities we have worldwide can connect to it using a single hop, which is really beneficial, like I say, when you've got this dispersed and decentralized workforce. So this environment worked really well for us. We had this probably operational for, I'd say, about 18 months or so, and everything was working really well, but we started to see a few challenges. And I think maybe this may resonate with some folks here. Maybe you're seeing some of the same challenges, or maybe you see the writing on the wall. So I'll talk through some of these internal challenges first, because these are the real showstoppers. The first one is that we're a technology company, and we've got a lot of presence in AWS right now. And with that, a lot of our product teams want to do testing. So they're testing these different workloads in AWS, and this, it's very easy to spin up and down instances in AWS, very easy to build environments. But a lot of these requests would come in with, we need access to the wide area network. We need to be able to connect back to corporate for LDAPS authentication or SQL application. Lots of different use cases, but ultimately they need access back. And as they're only internal, it's a reasonable request. We have to be able to facilitate it. So we were building VPN tunnels from some of these environments back to some of our data centers. That really only works well, though, if your destination of your traffic also resides in the same data center. We don't want to be building VPN tunnels all over the place. And ultimately, you can already see from a scalability perspective, these VPN tunnels are not going to scale very well. We're going to have tons and tons and tons of them. The more accounts you get, the more VPCs, the more IPsec tunnels, ultimately becomes a bit of a headache for the folks involved, and also for us to actually have to manage it. We can use CSR 1000Vs here. We mentioned the single hop hub and spoke environment of the wide area network, and we did do that. We have many environments that are actually currently out there using CSRs, so these business teams can access the CSRs directly in those VPCs. But the problem with that is, again, scalability-wise, it's more devices to administer, it's more EC2 compute cost for those CSRs, and it's more licensing. And Cisco might like us to do it, but no one wants to pay for tons of licensing. So it ends up being a situation where, again, scalability is the problem. Another aspect of it there is the control. So one use case we would see quite a lot of was where someone would come to us and say, we want to be able to build a pretty high-spec server. We need this very soon, and we need it for a short amount of time. And like most organizations, we don't keep monster servers sitting in our data centers waiting these kind of requests. So this is a perfect use case for AWS. We say, yeah, we can do this, but we don't really have an infrastructure for you right there. And we could put it in the IT core, which we've developed. But if we put it in there, we can't really give you control of it because it's an IT account. And you start getting into the whole, how do you attribute a cost center for these specific instances? Do you want IT to actually govern it and actually host the system for you? We didn't want to go down that route because, one, it would be very difficult to kind of break out granular control so that folks could do what they needed to do with that environment, because ultimately at scale it wouldn't work very well. But the other reason was because we don't want folks to be actually contained like that either. I mean, the beauty of working in AWS is that agility and flexibility it offers you to be able to spin up and down those machines and change security groups and work within that fabric. And we wanted people to have their own VPCs in their own accounts with their own flexibility. And ultimately, as I say, from a scale perspective, this was going to be a bit of a problem. The nature of these VPNs was also changing. So I mentioned that we would facilitate these use cases by building IPsec VPN for people. And that, that worked well, but at the same time, we're also moving some of our IT workloads into our IT core in AWS. So we have a situation now where we've got VPC up here, needs to talk to something which we've now migrated into US East IT core, and we're connecting to it via on-premise. Obviously, we don't want to be doing that. So we had to, again, you could see this coming. We didn't get into these situations, but it was inevitable. So we needed a solution that was allowing us to keep all that, keep a more holistic approach to the network, and actually make sure we were governing everything in the one area. And this is where the Transit VPC really came in. The final aspect here is segmentation and staging. So if you were onboarding an acquisition company, or you just had a new or untrusted area, we didn't have a good way of actually maintaining a staging presence. So we would have a limited amount of connectivity between this AWS presence and our IT core, or even our on-premise. How do we manage that? How do we manage staging in a good way? We also had an external challenge, and this is something that you may or may not have seen this already, but this is something that we struggled with. So in Infor, we had a lot of internal applications, like I say, move into this IT core. And we're, like I said, we're very AWS focused, so a lot of our newer applications were going straight into AWS. But we also wanted to provide public connectivity for our own internal employees so they could access some of these internal applications via apps and web front ends, like this is smartphone and tablet access, that kind of stuff. So the teams involved were using the Amazon best practices of building public presence with load balancers. We want to have redundancy, so we want to have several web servers. But because the environment we have here is an internal environment, it doesn't lend itself very well to having public ELB or public ALB with firewalling, which is what we wanted. This is like I say, this is an internal environment. We wanted to have it firewalled. But if you try and get firewalls working with ELBs and ALBs, and I see a couple of people nodding, you have problems because there are some challenges there. The amount of listeners you can configure and IP addresses rather than DNS names, et cetera, et cetera. So when we hit this particular problem, there are a few solutions you can use. We trialed this solution with auto-scaling groups, and it works. It really does. but it's essentially over-designed for the use case we had. It's designed for a completely different use case. And what we wanted was multiple public presences, multiple ALBs and ELBs with very low throughput. I mean, auto-scaling groups was just not the right answer for us. So we trialed this, like I say, but it didn't really play for us. So then the Transit VPC was announced. This was last year. And when this Transit VPC initially came out, I was pretty excited because this was literally answering so many of the problems that I was experiencing. I got straight onto this and we started labbing it and testing it to see if it could address these concerns. So as Jim said, this is something you launch from Marketplace, and the big win really is that it addresses the biggest limitation within VPC. VPC is non-transitive. So we have your A, B, and N here at the top. You could have, A can talk to B or B can talk to N, but A can't talk to N via B because of the non-transitive nature. So when this initially came out, we deployed our first iteration and so forth, and I'll go through a run through on the actual, like the tech behind it essentially, and why it was a really good thing for us. So it's deployed using a pair of CSR 1000 Vs. This is done from a CloudFormation stack. You basically launch it and build it, and it will configure the entire environment for you. It's very easy to deploy. It's multi-region and multi-account support. So you have some limitations in peering, the cross-region peering limitations, which if you want to use peering and connect, you have these problems. So this takes care of that. You can go across regions, and very importantly, you can go across account, which is where, like I say, we wanted to leverage this keep people in their own accounts mentality, keep them in their own cost centers, have them under their own control. It uses BYOL licensing. So BYOL licensing is a big win for us because if you've got a relationship with Cisco, you can get some pretty attractive pricing. But using the eval model alone, just to get yourself off the ground and trialing it, it's a really nice solution. It's reduction in cost and the actual overall administration. I mentioned the scaling problems we had with the VPNs and then the CSRs as well. The CSRs, they have the compute cost, they have the licensing cost, but they have the administration as well. And when you're homing multiple situations, like multiple tunnels coming into firewalls and data centers, you've got to manage all of that. You've got to manage, is this tunnel up, is this tunnel down? Do I need to reset this? A lot of admin. But when you look at it from the cost perspective, those CSRs that you have, if you have 5 or 10 of those sitting in US East, and you can collapse them into one transit VPC, you just save yourself a lot of money there. So that's an obvious win for us. And again, because we might have had CSRs in different accounts, the fact that CSR can support, or the transit VPC can support multiple accounts, that's not a problem anymore. You can actually say, I can just take down my CSR footprint, build it in a transit VPC, and I can still leverage those additional accounts. The solution is an AWS initiative with Cisco. So if you see the AWS documentation on Transit VPC, it's all about Cisco, the CSR solution. And that's a really good thing for someone in my perspective, because when we initially started working with this and we were getting our feet wet with it originally, we had to work through some questions in some areas that we weren't sure on and how we would address them. And I ran into some problems with some just obscure issues, as you do, and I was able to have situations where I'd have Amazon and Cisco on the phone at the same time, because this initiative being kind of it's like a collaborative initiative. It gives you a real peace of mind because you're not going to have a situation where one vendor is saying, not our problem, those guys, and throwing it over the fence to them, which is really good for like I say, someone in my position. The solution is WAN agnostic, so you can run any amount of services on the Transit VPC routers themselves. As Jim was saying, they don't necessarily recommend it, but you can run DMVPN on them. You can run IPsec. You can connect them whatever way you like, but you don't have to. And you can migrate them. You can connect them to your data center in like the usual connectivity means. You can use DMVPN, IPsec, or direct connect. You've got all those options. So you're not really tied into anything. Whatever you want to do is basically how it'll best work. Jim mentioned zone-based firewall. This isn't a specific to the Transit VPC, but it is a real benefit for us. And the reason is because if you want to use the segmentation the challenge I mentioned earlier, and staging, you can use zone-based firewall for that. So this is, again, something we use on-premise on our ISR and ASR routers. And when you look at what you can do with, say, zone-based firewall, if you look at A, B, and N on up the top here, you could set zone A as being, this is a fully routed environment, so it has access to all other zones. Zone B is a staging environment. It doesn't have access to anything until it meets certain requirements. Like it has to be, the servers have to be hardened, or there needs to go through some security compliance checks before you say, okay, you're good to go. And then you can change its zone membership to be something that is actually fully routed. So you can say zone A talks to zone B can talk to zone N but not the WAN, zone N can talk to only the WAN but not zone A, etc. You can create as many zone pairs as you want in different policies, which is great because it allows you that control over the entire environment. You can ultimately, you can secure it as much as you need to. The use of redundant links in BGP, again, this isn't a specific advantage, but for our case it is. So there's a lot of different ways to do redundancy from a network perspective in AWS. You can use a lot of API-based stuff, ENI shifting and route shifting. And we've used a bunch of them in different cases. But the redundant links with BGP is really beneficial because of the way we actually connect to the wide area network and to other services. And I'll detail more about that on our next slide to illustrate why that's kind of an advantage for us. And finally, automation. If you've seen the Transit VPC in action, this automation element is a real eye-opener. It's fantastic. This allows you to bring up these environments and these spokes very, very quickly, and allows you something that I don't think it's not very prevalent, is while we're all used to, temporary instances and temporary environments, this allows you to really build temporary networks. You can connect up one of these zones, like a zone A or spoke VPC here, and it will be connected within a few minutes. You can use it for as long as you like, and then you can disconnect it, and it will deconfigure everything. It removes everything again for you. So that concept is actually really helpful if you want to trial things. If you want to trial a different means of connectivity, this kind of temporary connectivity is actually is a really good thing. So this is what the Infor Transit VPC looks like. I hope people at the back can see this. It's quite an involved diagram. So what I'll do is I'll break this into chunks because it's got three essential functions in it. There's the transit function, the WAN function, and the firewall function. And I'll explain a little bit about each. So to start off with the transit function. So the central area here, and I'll just point it out here, this VPC here is our transit, this big guy here. And as you can see, there's a few different bits and pieces going on in there, but that VPC there has got two routers out to the right, and they're called the CSR transits. So when you build when you go to Marketplace and you run the Transit VPC solution from there, it will launch that CloudFormation stack for you. And what that will do ultimately, you will basically fill in the gaps. It's very much like your stock standard template. You can customize it, but if you just launch it straight from the Marketplace default, it will ask you, what subnets you want to create it in, what CIDR block you want to use, the sizes and throughput of the routers, et cetera, et cetera. It will also ask you what you want to call the tag that you're going to look for. So to explain how this works, those spokes on the outside, the automation element here is basically based on tags. So when you create a spoke VPC, it's just a VPC that you've created already, you give it a tag that you've configured at launch time, and on finding that specific tag, the Transit VPC brings the environment in and connects it. So when you're first launching the stack, you have to tell it, what's the name of the tag I'm going to look for? And a tip here when you're building this is call it the same as the actual region you're building it in. Don't use the default. So if you're building this in US East, call it Transit US East Spoke. You'll thank yourself in 6 months' time when you start bringing up EU West or something like that. Because you got to remember, this is across the same account. If I build this in the IT account right now, if I set up another region, I'm still in the same account. And when I build that CloudFormation stack, it will allow me to search my entire account for any VPC with that tag. So as I create these new spokes, it's good to have regional identifiers. You know which region, which regional transit VPC you want to connect to. So building this, when you create this first tag here, you say, okay, I'm going to call this one Transit US East spoke. That's the spoke I'm going to look for. I launch the CloudFormation stack. And what it does is it builds those CSR transit routers in the availability zones, in the subnets you've specified, and builds the rest of the environment. It also creates a Lambda polar and a Cisco configurator. So the Lambda polar is going to sit in that IT account, and it's going to poll that account every 60 seconds. And it's looking for the presence of the tag that you've created on any VGW, on any VPC in your account. So when you launch that, when that polar starts running, you go to your VGW in the spoke VPC that you've created. You say, okay, I'm ready to connect you. You're going to be my first spoke. And you say, you put in the details. You go to you create a VGW. You then say Transit US East spoke is true. That's the tag it's going to look for. You also have the opportunity at this point of putting in a second additional tag. You don't have to. But the second additional tag is to tell it if you would like to prefer one of the transit routers over the other. And what that does is, first of all, you enter the tag as Transit US East Spoke Preferred Path, I think is the syntax, and you say CSR1, for example. And what that actually does is, you don't have to do anything beyond that. It tells the configurator to configure CSR2 with AS path prepend on BGP. So it makes the CSR transit router less preferential, essentially. It's less preferable route. So it still works, but you're not using it as your primary. The default, if you don't put that in, is to use equal cost load balancing. So in our situation, we did use the prefer CSR1 over CSR2, and I'll get to why we did that in a sec. But you can use either. So that's you setting up the IT account with a new transit spoke. And when you, like I say, when you launch or when you enter that VGW tag, the polar finds it and says, we've got one. Here's a live one here. We're going to actually configure this. What it does is it launches the Cisco configurator to build the configuration on the transit routers. So it will configure those transit routers with tunnels. It'll configure the IPsec ISACAMP and IPsec profiles and policies. It'll push it out to the Cisco transit routers, and it'll bring up tunnels. It'll also do the same on your spoke. It'll create dual VPN tunnels, and it'll build VPN tunnels from there back to both transit routers. It actually builds 2 per transit router, so you've got a total of 4 tunnels. It also then configures BGP overlay over the top. That's all done from the presence of that 1 or 2 tags. So that's what I meant from the automation point of view. That's all you have to do. You've already pre-configured the kind of framework for this. Adding the tag just builds the infrastructure. So that's your IT account. Your IT account is up and running and it's all working fine. So how do you do an additional account? And this, like I say, is, from our perspective, is the major one. We obviously have some IT spokes, but it's the additional accounts that you really start to see the wins. So the IT account by default is whitelisted because it's the one that owns the actual Transit VPC. So if you want to add additional accounts, you need to whitelist them. So you go to the S3 bucket that actually homes the configs, and you say, I want to add the account number of the additional account. In this case, if you look on the top right, up here, my pointer's gone, there's one there called Infor Krypton, and that Infor Krypton account ID is added as a whitelisted account on the S3 bucket. Then you launch a CloudFormation template in the additional account. Now this is, you can actually go straight to the AWS documentation page for Transit VPC, and there's a clickable link right there to launch that template. You can again customize it whatever way you want, but right from literally the documentation page, you can launch that and it will bring it up for you and deploy what you need. This is like a kind of a cut down version of the original CloudFormation stack. It will launch the polar into your additional account, so you have your Lambda polar set up in there also. And when you create the tag, it runs, the same process happens. The polar is sitting there, account is searching it for every 60 seconds. And once it finds the tag it's looking for, it says, okay, I found the tag, and it will build a configuration, VPN connections, IPsec, ISACAMP, tunnels, BGP, the whole lot. Again, you can use your AS path prepend if you like. And that process takes about 5 minutes to run that. So I've had like product teams on the phone showing them this, like, you know, sharing a screen, and they're saying, okay, here we go. Let me see your screen. Let me show me the VGW. Let me enter the tag. We enter the tag, and then I go to the VPN connections link in VPC, and I refresh it, and you just see pending, 2 VPN connections coming up. And then you see available, and then I say, okay, contact the environment now from whatever remote office you're in, and it works straight away. And they're amazed, and it's a really good feeling because it's literally that easy. It takes, like I say, 5 to 10 minutes, and the entire operation is complete. And you can also decommission it just as quickly. So if you want to remove it, you can clear that tag. Polar again finds that tag, and it basically deconfigures everything. Takes down your tunnels, takes out the whole lot. So I mean, it's worth thinking about how you control that, so you don't want people accidentally deleting it. But you can govern all that as well with, you know, with policies and roles. So that's the transit function itself, and that's how that operates. The second part of that is the WAN function. So I mentioned that you can configure all of your WAN connectivity on the transit routers also, but we didn't. So why separate? So for Infor, we were looking a bit further down the road. We were looking at SD-WAN, and, you know, connectivity means using, an orchestrated push of an SD-WAN configuration. So we didn't want to, you know, have our CSR transit routers doing anything except being transit routers. We wanted to be able to sort of, you know, keep our WAN functionality kind of kept aside, and the transit function is their only real function. And there's another thing as well, which is, you know, it may or may not be applicable to you, but it's relevant to mention. The CSRs are licensed by throughput. So if you have CSR transit routers, and if you look at the spokes, some traffic will never touch those WAN routers out to the left, those CSR DM VPNs. It'll only ever touch the transit routers because it'll be just a spoke talking to another spoke. It's much easier to plan for what your throughput's going to be when you know what that traffic's going to be. As Jim has mentioned, if you had contention issues, you could always introduce peering across them if you wanted to move massive traffic across there. But generally speaking, we don't want to get into a peering bird's nest, essentially. So we wanted to keep this solution working as you see on screen there. And that's relatively easy for us because of the way this is actually configured. So we do keep them separate for that reason. So how we actually introduce WAN connectivity then is those the CSR DM VPNs, the routers out to the left here, they communicate with the transit routers using BGP. And once again, we use AS path prepend to keep things predictable and consistent. And this works, like I say, it's the same situation we're using with the spokes, which makes it easy to troubleshoot and to support for our organization also. So that's the wide area network function. We have one other function here, which is called the firewall function. So if you look at the bottom there, there's 2 application firewalls that are present as well. And they essentially serve 2 purposes. So first, they handle all internet egress for the actual spokes. Now, this again is, it's up to you how you want to deploy this. For Infor, we wanted to have control over those, the internet traffic from all those spokes. We wanted to know exactly what was happening and have visibility of it as well. And we, you can introduce all kinds of other services like IPS and whatnot there. So this is kind of a little bit like a transit hybrid with a services VPC. If you're familiar with a services VPC, it's kind of similar. And how this works is that when we actually build a spoke, our process is, this is an internal only environment. You can't connect anything public to this. And that's the means in which we've actually delivered the centralized internet connectivity egress. So what that means is that, and this can be a win for you as well when you think about it, the spoke VPCs have no business having an IGW because they can't have internet connectivity, they can't have public IPs. So from a security point of view, we know what they're doing from the network because it's all coming through us. They don't have any ability to create IGWs. And they have, from managing it essentially, because this is internal, once you talk about additional accounts, you obviously want to know what these additional accounts are connecting to and are doing. But when they can't actually go out on the internet or they can't create EIPs or whatnot in these different VPCs, you're in a much better position because you know you're controlling your own security. So that was a bit of a win for us to do it that way. And how we handle it is basically, if you look at those application firewalls, they're talking to the transit routers using, surprise, surprise, BGP and AS-Path prepend. And they communicate back to the transit routers. They deliver a 0 route to the transit routers, which the transit routers then propagate out to the spokes using BGP as well. So this is why we introduced the prefer CSR1, don't prefer CSR2. Because if you do equal cost load balancing, then you have stateful firewalls, problems. So this is why we did it that way. The second function that the firewall actually handles is, I mentioned the challenge we had from the external side. And the external challenge was having the ALB and ELBs running with an inline firewall. Again, we're talking about an internal environment. We want to protect it. So what we did was we built this VPC down the bottom right here. And we call it, it's like a DMZ of sorts. We call it our production VPC. So in here, we have a VGW, which, like our transit spokes, is connecting back to a pair of application firewalls, the same application firewalls that are handling internet egress. Again, scale out if you want. If you need to add extra capacity there for additional throughput. I'm using them right now because we don't actually have that much throughput load on them. But there's, again, 4 tunnels. There's like dual tunnels from each VPN connection to each of those application firewalls. And the DMZ VPC itself can then home native ALB and ELB. So we can have our services running in there, and they can be accessed over the internet. You see from the little icon on the bottom right there. And once they've hit the appropriate web servers in that pool, they will then traverse back over the firewall perimeter, which is where we have our ingress control, and we will then send the traffic on to the actual destination. It could even be over the WAN, but I mean, generally speaking, it'll be in AWS in our IT core. And I've got a quick slide which shows what that traffic flow will look like. So if you follow the green arrow here, essentially, traffic comes in from the internet, it hits the ELB or the ALB presence, it then traverses the line over to the firewalls. There's your firewall perimeter layer where you can then, at layer 7, decide what gets through and what not. It then goes across the transit routers, and it goes ultimately to its destination. And at that point there, I think what's important about this slide is it illustrates the amount of redundancy you have in this. So you've got up to 4 tunnels straight from that VGW. You've got dual firewalls. You've got dual CSRs. You've got up to 4 tunnels connecting back to your destination. There's a lot of things in there that can go wrong, and you're still going to be absolutely fine. And this is, the nature of the design is to keep it as, with maximum uptime. So I think that's about it from me, slide-wise. I would like to say, just to finish as well, I would urge you to try it. I mean, Jim mentioned it's, you can download an eval of this straight from Marketplace and trial it out and so forth. It's very easy to run. It's very easy to deploy. And the solution, again, lends itself to easy automation. If anyone's around for any questions afterwards, I'll be around later, but that's all I have. So I'd like to thank you all for listening, and I'll hand back to Jim.
Thanks a lot, Steve. Good stuff. All right, as Steve was saying, that's about it. But before you go, if you want to learn more, here are some sessions that are can't-miss sessions. If you want to learn more about networking, advanced networking on AWS, there'll be references to the Transit VPC solution, specifically with the CSR. These sessions include two of our very gifted principal solutions architects, Matt Lewis and Nick Matthews. Their sessions are usually can't miss. They're wizards, quite literally. So take a look at those. There's another slide with a few more. And I think that's about it. So again, try to get those if you need more information on networking for AWS. And that is it. We are done. We'll be in the back of the room with some solutions architects from Marketplace and product management from Cisco. If you've got any questions, just seek us out. All right, thanks a lot.